ठीक है। अच्छा जी, तो we had said कि we can break down a vector into its components, horizontal and vertical component, and then the use of breaking it down into its components. It would be one example that we discussed was that of projectile motion. So if we have this projectile, for this we said that the law of inertia tells that velocity, it would continue to remain the way it is, whether zero or of a constant value, until a force it acts on the object, and force it would create acceleration. So therefore the velocity would change. Then we said that for this projectile, if we one way to look at this projectile is to take velocity as a whole. But a more meaningful explanation of this projectile would be that we have got this projectile and the velocity that it has, it's broken down into its horizontal and vertical component. Okay. So if we break it down into horizontal and vertical component, then we learn that there is no air resistance or there is no other force which would affect its motion along x-axis. So whatever the motion along x-axis, it continues to be the same throughout the projectile. The value of Vx stays the same. However, for the value of Vy, there is this force of gravity which is acting on the object, which would cause the vertical velocity, which is initially upwards, to decline, and it keeps on declining until the object it reaches the maximum height, and that height would be maximum for the reason that it has lost all its vertical velocity. Since it has lost all its vertical velocity, it will not gain any further height beyond this point. So at this point, Vy is 0. And then the same pull of gravity towards the earth, it keeps on increasing the value of Vy until it reaches the ground with the same velocity, with the same magnitude of vertical velocity with which it was initially launched. This is the case of a projectile which is launched at an angle. And let's look at another example now. Let's say somebody is standing at this cliff, at the edge of this cliff. Okay. So here, this person, here is a football over here, and there is this boy standing over here. So what this boy does is he kicks the ball forward. Okay. So the velocity that he is giving to the ball is only along the x-axis, right? So here I have ux is equal to, let's say, 5 meters per second.
ठीक है.
Okay. So this ball, it will also follow a projectile. It would come to the ground following this curved path. Fine. Acha. Then what he does is it would take some time to reach the ground. Let's say whatever X amount of time. I don't have the value right now. I just say it takes some time to reach the ground. Okay. After that, what happens is that the same boy from the same height, what he does is he now drops a ball just vertically downward. So he just lets a ball go, and this ball just comes down straight in line to the ground. The question is that this ball, it takes a time, let's say x2. This was x1. Let's call first one x1, and let's call the second one x2. The question is, would x1 and x2 be same or different, and why? So if I kick a ball forward and it follows this curved path towards the ground, there is no air resistance. And I just let a ball fall to the ground straight down. Would the two
जी.
balls hit the ground at the same time or different times?
ठीक है. Different times,
Different times. Why?
because ball that's like going in the curve, it's
Hmm.
covering more distance, so I guess it takes
ठीक
more
है.
time
ठीक है.
because of that.
अच्छा जी. What would actually happen is that both these balls, they'll hit the ground at the same time. Let's see why.
Mm.
Madam, for the ball to fall down, Would the forward velocity play any role in the ball coming down?
Sorry?
Would the forward velocity, so if I give something a velocity forwards, would it mean that it would go downwards as well? Would this forward velocity play any role in the ball coming down? For the ball,
Sort of.
both the balls to come down, it has to be vertical velocity. Vertical velocity would determine when the balls they come down, and vertical velocity for both the balls would be the same. Okay, so initially both these balls, the one kicked forward and the one just dropped, their vertical velocity is zero for both of them. Got it?
Ji.
And both these balls, they would follow, they would have the same acceleration, which is 9.81 coming towards the ground. Since they are covering the same vertical distance towards the ground, let's say okay, this was 20 meters, this height. Okay, so the vertical distance covered by both the balls is the same. Hence, they would both hit the ground with the same velocity and at same time. This thing understood? So whether a thing
Not
is,
really.
acha, let's look at it again from the start. Let's look at it again from the start, no problem. Acha, let's go back to the previous example. You understood this example, right? The first projectile example that we discussed
Ji,
yesterday.
ji,
Okay.
ji.
In this one, what was happening is that a ball, it had ux and uy, the initial velocity that was given to the ball. Ux, it remained the same throughout the motion. Why? Why did this initial velocity Vx remained the same throughout the motion of the ball?
Because there's no air resistance.
There is no air resistance and there is nothing which is causing a
Nothing
hindrance
against
in the
it.
forward motion of the ball, right? As
Ji.
for the vertical motion, the force of gravity was acting.
Hmm.
Did the force of gravity affect the forward motion?
Nahi.
Okay, so the force of gravity which is along y-axis, it would only affect the motion of the ball along the y-axis. Understood?
Ji.
Acha ji. Now again to that cliff example. So once again, there is this boy standing at the edge of a cliff. So first what he does is he kicks this ball which follows a projectile like this. The ball is kicked forward. Ux is given and Ux is 5 meters per second. What is Uy for this ball? Initial vertical velocity. Ji madam, what would be the initial vertical velocity for this ball?
Initial vertical velocity. Vertical velocity would be zero.
Zero. Because he is just kicking the ball forward. There is no, I mean, he does not give any velocity to the ball downwards. He just kicks it forward. But the ball would come down as well. Why would it come down? Because there is acceleration due to gravity which is pulling it down. But again, this acceleration, it comes into play when the initial vertical velocity was zero, right? In this particular example. Understood?
Yeah.
So if I want to calculate the time it takes to fall down, I would say I would use this uy is 0. I would use a is 9.81. I would use s is equal to whatever, but I would just take the vertical motion of the ball or the vertical distance if I want to find out how much time it takes to fall down vertically. Understood?
ठीक
I
है.
would not take a vector from here to here. This is not the distance that I would use. The distance that I would use is the first one, the height. This is not to be used. You understand why this distance won't, no, won't be used? The one that I've crossed out.
Because
because the velocity given, the acceleration given is not along this green distance, they are along the black distance, the height that is of the cliff.
ठीक है.
Okay. Acha. Now let's consider another ball which is over here, and this ball is just let go of and it drops vertically. So what's the initial vertical velocity of this ball? Again, zero. What's the acceleration that this ball is experiencing? Same, 9.81. What's the vertical distance that this ball is going to cover? The same as the first ball, right? So
Hmm.
the time taken for this ball would also be the same as the first one.
ठीक है.
Understood now?
जी.
ठीक है. Acha ji. So again, this parabolic path, this was the first example. This thing falling off the cliff, this is the second example. And the two balls falling off the cliff, one pushed forward and one simply dropped down. And we learned that they both take the same time to reach the ground because the along the vertical fall, the initial velocity, the acceleration, the distance covered is same for both the balls. Therefore, they would take the same time to hit the ground. Okay. Uh, Third example is that again, another boy standing over here. He has a ball in his hand. He takes this ball, throws it vertically up. The ball goes on and reaches a maximum height, and the ball it comes down again. So this time the velocity of the ball is he throws it upward with a certain velocity, let's say 3 meters per second. Yes. Acha ji, the
ठीक है.
ball it would experience an acceleration negative 9.81 meter per second squared. At maximum height, the initial, sorry, the final velocity of the ball it would become zero. Final vertical velocity. Acha, for this example, there is just vertical velocity, whether initial or final, because I'm just throwing something up and it's coming straight down. So there is no movement along the x-axis. Understood? No?
जी.
Achha, understood. Achha, so once the ball it reaches the maximum height, so this would be one portion of the motion. And for the second portion of the motion, now I can start again and I can say uy is 0 because the final velocity of the first portion would be the initial velocity of the second portion of motion. Now the acceleration will be 9.81 because for the complete question we have taken downward to be positive and upward to be negative. So that would mean the initial velocity that I've taken downward as negative. I've taken downward as negative. So I'll use upward as positive, downward as negative. So uy is 0, a is minus 9.81. By the way, for this second phase, I can take a different scale. I can say that downward is positive as well. Anyhow, if I still take downward as negative, the final vertical velocity would also come as negative because it would be in the same direction as the acceleration. So signs are important. Whenever we are using the sign, we should know what frame of reference that sign represents: upward, downwards, left, rightwards, leftwards. So it
ठीक है.
would. Hmm,
Could you just खत्म करो फिर.
I don't understand.
Could you just repeat from the beginning? I'm getting a little confused.
ठीक है. Which exam? Both the exam, the cliff example as well, or just this one?
Just this one.
Okay. So we have got a boy. Any confusion in this? No.
नहीं.
The boy has a ball. Again, no confusion. He
नहीं.
throws the ball upward with a velocity uy. Okay. initial vertical velocity. Let's
ठीक
give
है.
it a value. Let's say 3 meters per second. The ball would experience acceleration due to gravity, which would be negative 9.81. Why? Because it is in direction
Gravity. जी.
opposite to velocity of the ball. If upward velocity is positive, then downward acceleration would be negative. And at maximum
Wait,
height,
wait. So I think, isn't it because like gravity goes downwards, so acceleration that goes against it will be negative?
acceleration is in the same direction as gravity. The ball is not accelerating
Yeah.
upwards, it is decelerating upwards and it is accelerating downwards. The direction
Yeah,
of
what I'm saying is the essence
hmm,
acceleration of gravity is going downwards
hmm,
and the velocity is going upward. That's why here acceleration is negative.
G. That is the reason. Correct.
ठीक है.
Correct. Precisely that is the reason. At maximum height, Vy will become 0. Okay. And
जी.
using these values, we can calculate the value of t, or we can calculate the value of s, that what's the maximum height that this ball would reach, or what is the maximum time it would take to reach the maximum height. The time it would take to reach the maximum height and eventually the total height that would be gained by the ball, they can both be calculated.
जी.
Yes? ठीक है. अच्छा जी, v is equal to ut, and so let me write down the equations as well. So if I want to calculate the maximum, the time it takes for the ball to reach maximum height, I will say v is equal to u plus at, and here v would be 0, u would be 3, a would be negative 9.81, and I'll find out the value of t. Similarly, if I want to calculate the maximum height that would be reached by the ball, I'll use the equation v squared is equal to u squared plus 2as. So again, v would be 0, u would be 3, a would be negative 9.81, and s would be the balancing figure that would be calculated. Yes, madam?
जी.
ठीक है. Now, if I want to consider the round trip, so what I would do is, okay, the same time it takes the ball to reach this height from the hand of the boy, it would take the same amount of time to from that height to reach back the height of the boy. Yes. So t for this upward journey will be equal to t for this downward journey, as long as it is coming back to same point that it was sent up from. Okay.
Okay, but one thing, what if it exceeds that point?
G, then the time will also exceed. So let's just assume, मैंने भी I haven't done the calculation. ये चलें कर ही लेते हैं. V is equal to u plus 8. V is equal to u plus
It's
8.
basically the same as the other one.
जी जी
Only
जी 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 जी
acceleration is
नहीं
possible.
नहीं, I'm trying to explain what the question, precisely the question that you just asked. So for that I just
जी.
need time. तो v 0 हो जाएगा, u 3 हो जाएगा, minus 9.81 t. Okay, so 9.81 t is equal to 3. T is equal to 3 divided by 9.81. G, the answer is
अभी मेरे पास कैलकुलेटर नहीं है, एक मिनट.
calculator. 3 divided by 9.81. There is always a calculator in the
0.3.
0.305 या 0.31 seconds. ठीक है, तो less than a second. I think I gave very little initial velocity, उस वजह से इस तरह आया. अगर इसको मैं 3 की बजाय 30 कर दूं तो ये 30 हो जाएगा, ये 30 हो जाएगा. 30 divided by 9.81 कितना हो जाएगा? 10 times the answer. So it would be 3.05. चलें, better. Let's see, 3.05 seconds. Yes. So it would take 3.05 seconds to go up. It would take 3.05 seconds to come back to this point. Okay. And if it exceeds this point, so it would be more than 3.05. अच्छा, वो किस तरह से होगा कि let's say again the boy is standing at the edge of the cliff. Okay, he has this ball, he throws it up, it gains maximum height, but instead of catching it back when it reaches the same height as the boy, it falls further down. So here now the time taken for the upward motion would be the different for the time taken for the ball to go from maximum height to hit the ground. Understood? So for this case, what we'll have to do is we'll have to find out the height at which this boy is standing. So for that further downward time, we will have to add for the journey based on the height it is standing at. Okay, we'll get to such questions. There are such questions coming ahead.
हाँ ठीक है.
Okay. So this is basically, I think, the majority of the cases of projectiles that we are going to encounter. They would employ or they would involve the logic of one of these three cases. If there is one which is any different from these three, so we'll discuss then when we get to the questions. Okay. Any questions from this that we have discussed in the lesson this far?
Other than the if it exceeds the starting point, no, everything's clear.
ठीक है. We'll get to, अच्छा वो जो starting point से exceed कर रहा है, I haven't given you the data for that one के how much it exceeds. Um, so
No,
let's
I
say,
just wanted to ask about
hmm,
uh how to say this, about the velocity. Will it
hmm.
stay the same or will it change when it goes exceeds the starting point or whatever?
So if it was thrown up with 30 meters per second, it would reach this point at 30 meters per second, and there onwards it is still accelerating at 9.81. So it would keep on increasing from this point. So next second it would become 39.81, next second it would become something more, next more. So obviously this velocity it would exceed.
Okay, and then what about displacement?
Displacement, very good. So let's see how much. So for this we just calculated it would take it 3.05 seconds to reach the maximum. Let's do for displacement as well. Acha. Again, v squared is equal to u squared plus 2as. V squared is 0. So I'm calculating the maximum height that this ball would reach. U squared, u is 30 squared, right? Plus 2 into negative 9.81 into s. So this would become 2 into positive 9.81 into s is equal to 900, and s is equal to 900 divided by 2 times 9.81. Any confusion in this calculation?
No.
Okay, it would become 900 divided by bracket 2 times 9.81. Acha ji, so it would reach a height of just a second. Okay, again, v squared is equal to u squared plus 2as. Fine. So if it is thrown upwards, u is 30. Okay, 30 is a lot, लेकिन चलें. 30 squared minus 2 into 9.81, so it will become positive 2 into 9.81. So the distance covered, the maximum height that would be reached by the ball is 45.8 or 45.9 meters, right? 45.9 meters. Yes, madam. That's what this was. I took it as a ridiculously high speed, so I got the same as the answer as well. The height that would be reached by the ball. G. Any confusion in
Hmm.
this? Okay. So the maximum
Wouldn't the
height.
displacement wait, 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 wait.
जी
For
जी.
the starting point thing, wouldn't the displacement be negative? because it
अच्छा
exceeds the starting point
जी just a second
and goes
जी
downward.
correct I'm coming to that. So what would happen is it goes up 45 meters and then it comes down 45 meters. So by the time it reaches the boy, the displacement has become zero, net displacement when it
जी
reaches back.
वो तो सही है.
And when then it goes down, so now the displacement it would become a negative value because the
Hmm.
upward displacement was positive. So the downward displacement it would gain negative and the magnitude absolute value, yes, it would be greater.
ठीक है.
I mean greater than zero. Depends on how much it falls further down. So for this
जी
round
सर.
trip, it goes up and comes back to me, displacement is zero. If it goes further down, then whatever amount it goes down by that amount the displacement would increase. जी,
जी.
did I answer your question? Or did you
जी
yourself
जी.
answer your question? ठीक है जी. अच्छा, understood. Now let's see questions. Shall we move to questions of chapter 2?
Questions of chapter 2. ठीक है.
End of
Is there
chapter.
anything else other than this?
Other than this challenge, let's confirm that too. Let's confirm that as well. As if there is anything else to in questions, I'll explain. Lekin, let's just be sure. David Sang. Here is the book. Mhm. Do you have your book with you right now?
जी.
Acha, meaning of acceleration. If a car is traveling or if a body is moving in a circular path, the body accelerates because the velocity is constantly changing because the direction of the motion is constantly changing in circular path. So even though if the magnitude of the speed stays the same, the velocity would still be changing because of the changing direction, and uh, the velocity would be changing, and that would mean that the body is experiencing acceleration, which we call centripetal acceleration. Yes, madam?
जी सर.
Okay. This then. Hmm. Okay. Moving forward, calculating acceleration, change in velocity over time. You know this thing, unit of acceleration, meter per second squared. Car accelerates. Acha ji, you know velocity time graphs as well. This is something that we have done before. Okay, what does it mean if the velocity time graph is a horizontal line? What does it mean if it is a line with a positive gradient but constant gradient, constant acceleration? Downward sloping line would mean that the velocity is decreasing, so the body is decelerating. If it is a curve, so curve would mean that gradient is changing. Gradient is acceleration, so the value of acceleration itself is changing. Not just that the velocity is changing, the acceleration itself is also changing. You understand this much?
जी.
Acha ji. Then the area under velocity time graph gives us the distance traveled by the object or displacement. This you also know. Um, okay. Acha, in labs, we use this ticker tape. Ticker tape thing we have discussed before in chapter 1.
जी.
Okay. Equations of motion. Acha, there is this derivation of equations of motion. Let's do that too. Good. Acha ji. So we have got these equations of motion which we have always been using. So now the question is, where do these equations of motion come from? So let's just first write down all the equations and then we'll do the derivation. Acha, we have got one equation for which we say uh, distance is equal to average velocity into time. Then there is equation v is equal to u plus at. Yes. And then we have s is equal to ut plus half at squared. Yes, madam. And then we have v squared is equal to u squared plus 2as. So these are the four equations that we have got, and we'll look at their derivations one by one. Any confusion this far? I mean, we haven't
नहीं.
even begun, so there wouldn't be any confusion. Acha. For the first one, it's simple. We say, okay, what is the average velocity of the object? Average velocity is the total distance traveled by the object divided by time. That is how we define the velocity, distance, rate of distance covered, or the rate of displacement of an object. Yes, madam? So for average velocity, if the velocity of a body is changing and I want to take average, how would I do that? I would have the initial plus final divided by 2. Okay, this is distance over time, and u plus v by 2 multiplied by time is the distance. So first equation was quite simple. Any confusion in this?
नहीं.
ठीक है जी. Let's just a second. Let me color it out. Mm, okay, जी. Here we go. Acha. For the second equation of motion, we simply have the definition of acceleration. So acceleration is a rate of change of velocity of an object. Change of velocity delta v by t. Yes. What is delta v? Delta v is v minus
V
u
minus U
by t.
by T.
So it becomes at is equal to v minus u, or it becomes at or u plus at is equal to v. Yes, madam.
जी.
So second equation also derived. Okay, ji. Acha, so once we have got the second equation, what we will do is, using the first equation, I would find out the value of v from the first equation that we have. So rearranging this one, I get uh, u plus v is equal to 2s divided by t. Yes, madam. And v will be equal to 2s, sorry, 2s divided by t minus u. This is the value of v.
जी.
I will take this value of v and put it in this equation. So this equation, it becomes, instead of v, I write 2s by t minus u is equal to u plus at. Agreed?
जी.
अच्छा जी, तो then it becomes 2s by t is equal to u goes to the, I mean, it adds, so it would become 2u plus at. Okay, then it becomes 2s is equal to, multiplying both sides with t, it would become 2ut plus at squared. Any objection?
नहीं.
ठीक है. Now dividing both sides with 2, I guess s is equal to ut plus 80 squared by 2 or half 80 squared. Yes, madam?
ठीक है.
So this third equation, acha, I'd recommend that you note down these derivations because you're expected to know these derivations and you could be asked to derive any of these equations for your exam question. Okay? Acha.
ठीक है.
Then
So they will ask. Sometimes they'll ask us in exams
they could
for
ask you to derive an
derivatives.
equation.
ठीक है.
Later on, you'll have formula for pressure as well. So, for example, pressure change in
Oh.
pressure is equal to rho gh, those sort of things. So, you could be asked to derive those as well. Okay.
क्योंकि I already know these derivatives, so
These derivations.
yeah, because I can. In my previous curriculum, ninth grade, they already taught
Mm-hmm,
us these.
mm-hmm, mm-hmm,
Yeah,
mm-hmm, mm-hmm.
I can see why they put this in 11th grade because in ninth grade I was suffering because of that.
Chale ji. Now life is easy. Suffering, it has to be done at some point of life, some point of time in life. So, since you have already suffered, hopefully,
But it was very unnecessary at that time.
suffering most of the times is unnecessary, but we won't delve into philosophical discussions right now. We would stick
Hmm.
to the syllabus. Acha ji. Then again, we have this equation v is equal to u plus 80. First, now I will calculate this equation s is equal to this one. From this equation, I will find out the value of time. Okay. So if I make t the subject, it would become t is equal to 2s divided by u plus v, right?
जी.
Acha ji. And now I would put this value of t in the equation v is equal to u plus 80. So I write v is equal to u plus a multiplied by, instead of t, I write 2s divided by u plus v. Okay. Acha ji, since I've got fractions on right hand side, so in order to deal with that, what I do is to make denominators for both of them same. The first one I multiply divide with u plus v, multiplied by u plus 2as divided by u plus v. So it becomes v is equal to square root u plus v. Numerator I would have u squared plus uv plus 2as. Fine. It would becomes v times u plus v is equal to u squared plus uv plus 2as. Uv plus v squared is equal to u squared plus uv plus 2as. Uv and uv cancel out. V squared is equal to v squared plus 2as.
ठीक है.
ठीक है जी. So here you have all these equations of motion derived.
जी.
ठीक है. This then equations of motion derivation you have done. Equations of motion, uniform acceleration. Acha, we know that there is a difference between decreasing acceleration and deceleration.
Decreasing acceleration and deceleration.
ठीक है.
ठीक है.
In decreasing acceleration, velocity increases. In deceleration, velocity decreases. Okay. So in decreasing
Same.
acceleration, velocity increases at decreasing rate. At decreasing rate, and deceleration, the velocity is just decreasing. So what does it mean that velocity is increasing at decreasing rate? Let's see.
Mm.
So I have an object whose velocity is 10 meters per second. Okay, so if I've got constant acceleration, if a is 2 meters per second squared, it would mean every second its velocity would increase by 2 meters per second. So after 1 second it would become 12 meters per second. After another second it would become 14 meters per second. After another second it would become uh, 16 meter per second, and so on. Agreed?
Mm. ठीक है.
Acha. Velocity decreasing acceleration would mean that, now I would write in a different color. Again, initially the speed was 10 meters per second. Then the first second acceleration was 2 meter per second squared. So after 1 second, velocity would become 12 meters per
Well,
second. Acha, then for the next second, instead of having acceleration same as 2, it is now
be
1.5
different.
meter per second squared. So
ठीक.
it would become 13.5 meters per second. For the next second, the acceleration would again decrease 1 meter per second squared. So it would now increase to 14 meters per second. So the velocity is increasing but at decreasing rate. For the first second, it increased by 2 meter per second, then it increased by 1.5 meter per second, then it increased by 1 meter per second, but it keeps on increasing. The velocity is not decreasing, it's still increasing. So this is decreasing acceleration. However, if this were the case of deceleration, and let's say that the deceleration was negative 2 meter per second squared, or acceleration was negative 2 meter per second squared. Uh, Initial velocity is 10 meter per second. It would become 8 meters per second, would then become 6 meters per second, 4 meters per second, and so on. Understood, madam? So here the
जी.
velocity is decreasing, and in decreasing acceleration, the velocity is still increasing. Sure, this we know. We understand the concept of terminal velocity. Or should I repeat that?
Terminal velocity is when air resistance is equal
Hmm.
to like velocity basically.
No. So for terminal velocity, what happens is that I have a falling body. So as soon as I let this body fall, okay, the initial downward force is that of weight. Okay, just when I am holding it in its position, there is no air resistance because the ball is not moving at all. But as soon as I let go, two things happen. First, the earth would pull it with 9.8 meters per second squared. That would be the acceleration. Yes. And the
ठीक है.
other thing that would happen as V increases, this would result in air resistance increasing. So as V keeps on increasing, air resistance keeps on increasing. So as air resistance increases, right now, initially, I mean time 0.1 seconds perhaps, there is W which is downwards, and air resistance is almost negligible upwards, almost equal to 0. Okay, so net force is equal to weight. It's just the weight. But as the velocity keeps on increasing, this downward weight is countered more and more by air resistance. So this net force is equal to W minus air resistance. So far so good. Acha, this would keep happening until this AR it becomes, until net force is equal to 0. And when would that happen? When weight is equal to AR, air resistance. When air resistance, which keeps on increasing until it matches the value of weight of the falling object. So when that happens, sigma f is 0, which would mean acceleration is 0, because no force, no acceleration. And since now acceleration is 0, whatever velocity at this point, this is the velocity with which the object would now continue its uniform motion downwards, and this is called terminal velocity. G. Did we learn the same thing
Hmm.
for IGCSE as well?
G.
And perhaps before. ठीक है,
Hmm.
ठीक है,
So
ठीक.
when
Hmm?
acceleration is equal to air resistance,
No, no,
basically,
no, no.
or
When weight is equal to air resistance, or
okay,
when
when
net
weight is
force on the body is 0.
net force on the body is zero, ठीक है.
Okay? Net force on the body is 0. So then the velocity that the body has gained by that point. Acha, this air resistance, to be frank, the terminal velocity, this concept, this is there in the chapter of forces, more discussed over there. But since we already know this thing, so I discussed. Acha, similar thing would happen if I let a body fall in a liquid. Instead of air resistance, I would have upthrust from the liquid, right? And that upthrust would keep increasing as the velocity within the liquid keeps increasing. The object would have decreasing acceleration, and that decreasing acceleration would keep decreasing until it becomes 0 when upthrust is equal to weight of the object. And at that point, the object would move there forward with a uniform velocity, which would be terminal velocity. So terminal velocity is not something exclusive to air, rather it is something exclusive to fluids, if I may use the term. So it can happen in air, it can happen for a body falling within a liquid. Understood?
G.
Acha. Nice, nice, nice. Understood. Let's see if there is anything else in the chapter as well. Not really. We've got questions only to solve now. Just a moment, please. Acha ji, so for these questions, if we look at question number 1, so first of all, what is the requirement? We have to calculate acceleration. What is the acceleration? Okay, so acceleration के लिए what are we given? We are given distance. We are given starting from rest, so u and v. So u, v, and s is given. We need to calculate a. But the other catch is that these values, they are given in kilometers per hour, and the answers that we have to get is in meter per second squared. So
G.
fine. What we'll do is K will first convert the values into meters and seconds. So for distance, it is quite simple. S will be equal to 1.4 times 1000 kilometers into meters. So that gives me 1400 meters. This is the value of S. No confusion. Acha ji, let's get to kilometers per hour. So 200 kilometers per hour. So in order to convert kilometers into meters, I multiply with 1000. And in order to convert hour into seconds, I multiply with 60 to get into minutes, and again with 60 to get into seconds. So in short, what you have to do is whenever you're given kilometers per hour, you multiply with 1000 by 3600, or you are simply dividing the value by 3.6. So 200 divided by 3.6, right?
G.
So this gives me 200 divided by 3.6. G, 55.55 to 55.56. Yeah, 55.6, let's say. Acha. So I have got meters per second. V squared is equal to U squared plus 2AS. Now I'll rearrange the equation. U squared plus 2AS. So V squared minus U squared divided by 2S is equal to A. U squared is 0, so that would be that. V squared is 55.6 whole squared divided by minus 0 divided by 2 times S. S is how much? 1.4 kilo. So 1400. So on calculator I write 55.6 squared divided by 2800. 1.104 meter per second squared. So it would be this one, 1.1.
Okay. What I was doing wrong, I guess, was I did not I was converting the answer in the end to meter per second.
वैसे भी हो सकता है, वैसे भी हो सकता है, चलें वैसे कर लेते हैं. अच्छा, तो इसमें क्या होगा, आपकी इनिशियल स्पीड, फाइनल स्पीड, डिस्टेंस, तो उसमें आपके पास मैडम आ जाएगा v स्क्वायर्ड. v स्क्वायर्ड कितना आ जाएगा, 200 स्क्वायर्ड डिवाइडेड बाय 2s, 2 इंटू 1.4. ठीक है, 200 स्क्वायर्ड होगा 40,000 डिवाइडेड बाय 28. 40,000 डिवाइडेड बाय 2 इंटू 1.4, तो 2.8 हो जाएगा, 28 नहीं होगा. अच्छा जी, द आंसर इज 14285, राइट.
ठीक है.
14285 kilometer per hour squared. So it would mean r into r, right? So what I'll now have to do is kilometer to meter I'll have to multiply with 1000, and each of the r's I have to convert into seconds. So this r would be 3600 and this r would be 3600. So answer multiplied by 1000 divided by bracket 3600 squared bracket close. So again the answer would be 1.102 or 1.1. Got it?
ठीक है.
If you did not understand the calculation, now is a good time to ask.
Everything I understood. Yeah. ठीक है.
ठीक है जी. अच्छा, next question. The ball given initial velocity, thrown, fine, angle 30, horizontal. What is the velocity at the highest point? What is the velocity? What is the velocity? So madam, if you remember what we did today for the projectile, or what we did yesterday as well, okay, in this projectile at maximum height vy is 0 and it is just vx. So at maximum height vx is v. Whatever the horizontal component is, that is the velocity of the ball. There is no vertical component. Yes.
जी.
Acha ji, so that would mean I simply have to find Vx, and I know if angle from horizontal is given, Vx is V cos theta. I could prove again as well. So if this is V and this is Vx, so cos theta is adjacent by hypotenuse. So cos theta is Vx by V, and Vx will be equal to V cos theta. So Vx will be equal to V is how much? 10, and then cos 30. 10 cos 30. Answer is 8.66 or 8.7 meter per second. So in this question, two concepts were tested. First of all, to know that when the object is at maximum height, there would be no vertical component of the velocity. There would be just the horizontal component, and that would be the total velocity of the object at that point. Understood?
Hmm,
No?
almost. If you
Chalo.
repeat it.
Ji. Let's go back to this projectile that we had drawn yesterday. Here it is. Okay. So over here, I showed you. Can you see where I am on the board?
Ji.
So here for this projectile, we can see that as the ball it went up, Vy kept on decreasing, and as it reached the maximum height, Vy became zero. And we said that it would be zero because if there were any Vy, it would have gone further up. Since there is no more vertical velocity, therefore it is gaining no more further height. Okay, so if Vy is zero, is the object standing still and just going to fall down vertically? No, the object still has got its horizontal velocity, and all the velocity that the object has at this maximum height, it is the horizontal velocity. So whatever is Vx, that is the velocity of the object at maximum height in this projectile. Okay. ठीक है तो for this now the diagram given, I now have to calculate Vx. And the next concept that is tested, so the first one was to realize the velocity that we're looking for is just Vx. The second one is to know how to find Vx, so you can draw the right angle triangle and use the cos theta formula, or you can simply know that if the angle from the horizontal is given, Vx is b cos theta. Yes, madam?
जी ठीक है ठीक है.
ठीक है. अच्छा जी, this, then the last one. Okay, this is interesting. So what's happening over here is that we have got a trolley which travels along a straight track. The variation t of the velocity, v of the velocity with over time is shown. Okay, so first thing we have to realize is initially that in this portion from this point A to point B, the trolley is decelerating. Yes, acceleration is negative.
ठीक
The
है.
other thing we have to realize is that this is velocity time graph and it's a straight line, so acceleration is constant. Yes, the value of acceleration is not changing.
ठीक है.
ठीक है. So the graphs which are given are acceleration and time graphs. So I can cancel this one because it shows in the first path acceleration is positive. It's not positive. Again, this one acceleration is shown as positive. This cannot be the case. So acceleration is negative. So these two, they show that acceleration is negative in the first path, in the first portion of time. So it is below zero, it is negative, and in this one also below zero, so negative. Acha ji, now what happens? After it crosses this time, t1 point, is the deceleration absolute value. So over here in the first one, if acceleration was, let's say, minus 3 meter per second squared, in the second one, is this value going to be I mean more than minus 3 or less than minus 3? In other words, is it going to be minus 1 or minus 4 in the next portion? The magnitude of the acceleration, the magnitude of the acceleration would decrease. The magnitude of the deceleration would decrease. Yes, so it
ठीक
would
है.
become from minus 3 it would become minus 1, or in other words, it is not decelerating as rapidly as before, so the deceleration has decreased. So it would be this graph. First it was decelerating more, then it was decelerating less. Got it?
हाँ सही.
So it
जी.
would be C and not D. Acha ji, we keep this physics lesson till here for today. What we'll